Alright, so we're continuing our topic on transformation. So this is 1.7 part 2. And I just want to draw your attention to some vertical shifts that we talked about. The one in the middle is our parent graph for our parabola. If we look at the blue line, that was just shifted up 2 units. So remember, outside of the grouping symbol, if it's addition, you move up that many units. If it's subtraction, you move down that many units. Another recap shifts would be this graph here. So if we're looking here, the one in the middle is your parent graph. And if you have addition inside your grouping symbols, that moves it to the left too. And if you have subtraction inside your grouping symbols, that moves it to the right 3 units. Okay. So I just want to draw your attention to this. Notice that if you have a negative outside of your grouping symbols, it's a reflection over the x-axis. If you have a negative inside your grouping symbol, that's a reflection over the y-axis. If I had, here are some additional examples. So let's say I had y equals, or that could be f of x, negative x, and then I'm squaring it. We know that negative isn't going to affect it, right? And that's why a reflection over the y-axis for the parabola causes it looks like there's no change. The same is true for the absolute value. The moment we start introducing the cube, right, that does create a change, or your cube root function. Let me show you some pictures. Okay. So here would be an example of a reflection over the x-axis. So I want to show you here that the negative is outside of these grouping symbols. And let's take a look at this first point, 1, 1. Notice that when you reflect it over the x-axis, the only difference in that point is the y becomes negative. The same is true for this point. Reflect it over the x-axis, 2, negative 4. This point, negative 2, negative 4. This point, negative 1, negative 1. So when you reflect over the x-axis, your y's become negative, your x's are the same. Here we have another reflection over the x-axis because the negative is outside of your grouping symbol. So 8, 2 goes to 8, negative 2, 0, 0. When you reflect over the x-axis, there's no change. Anything that is on the x-axis, and I tell you to reflect over the x-axis, it stays on the x-axis, kind of like your reflection points. Same with the y-axis. And we had negative 8, positive 2 went down to, I'm saying this backwards, negative 8, negative 2 reflected over the x-axis, negative 8, positive 2. Notice that if I were to reflect 8, 2 over the y-axis, it's going to be negative 8, 2. So here, whether the negative was inside or outside the cube root, the graph appears, or it is, the same. It's the same effect. However, if I verbally ask you to write and tell me, does the negative outside produce a reflection over the x-axis or the y-axis? You need to know the difference there. Okay, remember a moment ago I told you that the parabola, that your absolute value, when you have a y-axis reflection, it causes no change because it has y-axis symmetry. However, we know that the square root function does not have symmetry over the y-axis, over the origin, over the x-axis. There's no symmetry there. So when we put the negative inside the square root, it reflects it over the y-axis. Okay. Well, think about what's going to allow you to take the square root. If you have the square root of negative 1, you can't do that if you're substituting 1. But the moment you substitute negative 1 into that, now you can take the square root of that, right? That's 1. And that's why your point is reflected over here. So when the negative is inside the grouping symbol, whether it's f of x is equal to negative x, and then we raise it to the 3rd power, that's a reflection over the y-axis. Or your negative is inside this cube root. That's a reflection over the y-axis. Okay, so here are the first examples that we're going to look at. So we are going to graph f of x is equal to negative square root of x plus 1. remember, always start by graphing the parent function. So I'm going to graph parent function. Here are some points that correspond, and now I can transform these points here are what I'm going to move. So you always want to graph first or transform first a horizontal shift and then reflect. Okay? Shift horizontally first and then reflect. So I'm going to move this left one. That would be here, because this is a negative. And then I'm going to reflect it over the y-axis. I'm sorry, over the x-axis because the negative's on the outside. I'm going to do them over the y-axis in just a moment. So no change to this point because it is on your x-axis. This point goes here, and this point goes here. And that's your final answer. Alright, so let's take a look at this one. So remember, start by graphing your parent so it's easy to transition some of these points. And now I'm going to reflect first before moving vertically. Okay? In a moment I'm going to show you the sequence of transition so that way it's easier for you to remember. So I'm going to reflect first. Because the negative is on the inside, I'm going to reflect it over the y-axis, and then I'm going to move it up 3 units. So let's go ahead and reflect over the y. 0, 0 reflects itself. 1, 1 reflects here, and then 4, 2, negative 4, positive 2. So that would be this here. And now I'm going to move it up 3 units because of the plus 3. And then we're done. Okay, so sequences of transformations. In some graphs, sometimes... Okay, so here are our sequences of transformations. When you have multiple or more than one transformations, you want to... The order does matter. Sometimes it might not make a difference, but in certain types of functions, it absolutely does. And I'm about to show you an example in just a moment. So first, always start by shifting horizontally, then stretch or shrink, and I'll show you some examples shortly on stretching and shrinking, then reflect, then shift vertically. Okay, so let's say I was given this graph, and I want to show you that the sequence of transformations matters here. Here is an example of that. So this is reflected over what? Over the y-axis, and it's also moved to the left 3 units. Okay, good. So here would be our parent graph, 0, 0, 1, 1, 4, 2, and it would exist like this. But let's say I didn't know that the order didn't matter, and I'm going to show you in blue the wrong way, and then I'm going to show you in black the correct way. So let's say I reflected first, and I got that. And then I went ahead and I moved it how? To the left 3. So 1, 2, 3, 1, 2, 3, and then that guy moves 3, and then I think this is my final answer. Okay, now I'm about to show you that the first thing you want to do is move horizontally because we just finished discussing that. And then, so this one is wrong. Then I want to reflect. Okay, so I'm going to move left 3, 1, 2, 3. 1, 2, 3. 1, 2, 3. So now you can clearly see that that graph's going like that. Now I want to reflect it. The reflection's over the y-axis. So this point here must be reflected over here. This point here must be reflected over here. Yep. And then this point that's on this side, 1, 2, goes here to -1, +2. Here. Now you tell me, does order matter? Yes. So remember, horizontal shift, then stretch or shrink, then reflect, then shift vertically. Alright, so now let's talk about our non-grid transformations. This is our vertical stretch, our vertical shrink. I like to think of the shrink as a compression. Like you're compressing all your y's together. You're squishing them down. So compression, compress. And what you're going to do is you're going to multiply the y's by C. If C is greater than 1, then it's a vertical stretch. It's going to pull all your y's closer to the y-axis. If it's a fraction between 0 and 1, then it's going to vertically compress. It's going to squish it down. And let me show you some examples. Also note that the x's will not change, so don't change them. Unless you're going to move horizontally, but we're strictly talking about non-grid transformations. All right, let's take a look at our first one, stretch and a vertical shrink. The parent graph is what's in blue. So if C is greater than 1, notice that the y's got pulled. So there's a pulled effect going, and it's moving them up that way, and it's pulling them down this way. If C is between the values of 0 and 1, note again, your parent graph is the blue one. Notice how it compressed closer to the x-axis. Your y's got smaller. Here's another visual example. So here on the left, we have our parent graph, 0, 0, 2, 8, -2, 8, also 1, 1, -1, -1. If we have a half in front of x cubed, notice that we're going to take that 8, we're going to multiply it by half or reduce it in half. That 2, 8 goes to 2, 4. That -2, -8 goes to -2, -4. 0, 0 is not affected. The point that was at 1, 1 here goes to 1/2 there. Here's an example of vertical stretching for the same parent graph. So if I said 3, this should say 3x cubed. So 3x cubed. Then your y's get multiplied by a factor of 3. So 1, 3 is now our new point, and -1, -3 is our new point. So that point got pulled. So let's do some examples. Let's take a look at the one on the left. We're going to notice that it's our absolute value function, and we're going to multiply the y's by a factor of 3. So always start with the parent graph. This is an absolute value function, so it's creating this identity relationship here and somewhat there. So now I'm going to take those y's and I'm going to multiply just the y's by 3. So I'm going to go from 0, 0 is going to stay, because when you multiply the coordinate point that corresponds to the y, it's going to stay at 0. Then 1, 1, 1 times 3. And then 2, 2, 2 times 3. So that gets pulled up here. And then I can reflect. Let's do that here and here. And then you can clearly see a vertical stretch. You're pulling it on the y-axis. So my next one, we have the absolute value function as well, but notice that this time C is half, so I'm going to reduce all my y's in half. Let's go ahead and graph our parent. So here's my parent. And now all my y's I'm going to reduce in half. So 0, 0 is going to stay. 1, 1, the y that's at 1 is going to cut down in half. And -1.5. So the x's don't change, it's just the y's. At 2, 2, 2 divided in half, 1. Same thing on this side. 3 reduced in half, 1.5, 1.5. 4 reduced in half, 2, 2. And then we can continue this pattern, but I think you get the idea. And last, let's put all of this together and do the sequence of transformations in order. Okay, so let's take a look at the first one. In the first one, we have a parabola. Remember, it's always a good idea to graph the parent. So 0, 0, 1, 1, 2, 4, negative 1, positive 1, negative 2, positive 4. And here's my parent. And now I'm going to do the transformations. First, I want to move, remember, horizontally. So how am I going to move this graph? To the right 3 units. So 1, 2, 3. And here's a shift to the right 3 units. The next thing I want to do is what? Okay. Good, I'm going to stretch it. So this one's getting stretched by a factor of? 2. Okay. So I'm going to multiply what by 2? 1. Good, so 3, that one stays. Then 4, 1, 1 times 2? 2. So that gets pulled there, that gets pulled there. And then the next point is going to be off, so I think that's enough. And then the last thing I'm going to do is what? Up 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. And here's our final answer. Final. Alright, one more example. This one's absolute value. So let's go ahead and graph the parent. I think that's enough points. So this is my parent. The first thing I'm going to do is move it left 2 units because of this plus 2. Remember, you want to shift horizontally. I just want to point out that there's a negative here. It's just blending in with the equal sign. So I'm going to shift it left 2. So 1, 2, 1, 2. And here is my horizontal shift. The next thing I want to do is compress it by a factor of 1/2. So now I'm going to cut the y's in half. This one stays. Reduce that in half. Reduce that in half. 3 to 1.5. And now we've reduced it in half. And you can see the vertical compression. The next thing we're going to do is reflect over the x-axis because the negative is outside the grouping symbols. So now I'm going to move everything over the y. Let's pick purple. Okay, and now we're clearly seeing where your graph is lining up at. And then the next thing we want to do is move it down 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4.